Okay, pre-calculus students, this is the first video for the 4.4 notes. This is where we're going to actually start putting together the radian measures and the special right triangles and actually start figuring out trig functions. First thing to talk about is what a reference angle is. That is always the acute angle from the terminal side to the x-axis. So let's say I had an angle of, we'll go in degrees for now just for simplicity. Let's say I drew an angle of 140 degrees. So 140 degrees would land me somewhere in the second quadrant. Again, this angle is 140 degrees. The reference angle always goes to the x-axis and it goes from the terminal side. So I just shoot down to the x-axis. So in this problem, the reference angle would be 40 degrees. That looks terrible, but that says 40 degrees. Always the tiny angle to the x-axis. The quickest way I can get to the x-axis. Never go to the y-axis. We're going to use the reference angles to find our trig values throughout this section and subsequent sections. The next little thing to talk about are the signs of the trig functions. And notice this is SIGN, so I'm talking about positive or negative. I learned this little, I believe it's called an acronym, All Students Take Calculus. I'm going to put those letters in the quadrants, starting with quadrant 1. So all the A will be in quadrant 1. Students will be in quadrant 2. The T will be in quadrant 3. Calculus C will be in quadrant 4. So all students take calculus. What this tells me is who is positive. So depending on what trig function I'm trying to do and what quadrant I'm in, that will tell me if I'm going to have a positive or a negative angle. So for example, if I said I wanted to find the sine of 230 degrees, what sign, SIGN, would this have? Would it be positive or negative? Well, 230 would land in the third quadrant. In the third quadrant, only the tangent is positive. So I know the sine of 230 degrees is going to be a negative number. If I had asked for the tangent of 230 degrees, it would have been positive then. So the first quadrant literally does mean all. All the trig functions are positive in the first quadrant. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent. And in the fourth quadrant, only the cosine. So again, this tells me who's positive. And as we go through the problems, I'll keep referencing all students take calculus, so we'll get very used to it. Okay, so how do I do trig on the coordinate plane? Well, first, consider just some point xy that's on the coordinate plane. If I shoot through that point with a ray, I can then build myself a little right triangle to the x-axis. Remember, because we're always building to the x-axis. Well, this horizontal length would be x, the vertical length would be y. That's how I get to xy. Now, for the hypotenuse, I'm not going to call it h, I'm going to call it r for radius, because we're going to reference this to the unit circle in just a little bit. If I wanted to know the sine of the angle, sine is opposite over hypotenuse, it would be y over r. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. Notice that I'm using the coordinates of the point to figure out the trig functions. That's a key here. Now we're going to lock this point onto the unit circle, which again means it's on a circle with radius of 1. So notice that I replaced r with the number 1. Still, if I build a right triangle, the adjacent is x, the opposite is y. Well, let's see what happens. Now the sine is y over 1, which is just y. The cosine would be x over 1, which is just x. The tangent would be y over x. That doesn't change. But what's key here is if I am on the unit circle, the sine is basically just equivalent to the y-coordinate of the point. The cosine is just equivalent to the x-coordinate of the point. So any x, y that is on the unit circle, I can think of as the cosine of the angle followed by the sine of the angle. These are equivalent if I'm on the unit circle. That's going to help us a lot. So now we're going to go back to this unit circle. And we're going to fill it in. And you have this on Blackboard, the filled in unit circle stuff. Make sure we're all ready to go here. And for these problems, I'm going to be referencing those two special right triangles. But I'm going to be referencing them in unit circle format. So let's start off with the 30, 60, 90. We talked about in the last video that the hypotenuse is double the short leg. Well, if I'm locked in on the unit circle, that hypotenuse or radius is 1, which means that the short leg is half of that. To go from the short leg to the long leg, I multiply by √3. So the long leg is √3 over 2. So essentially what I have here is the 30, 60, 90 right triangle, but where it is locked into the unit circle. So what the heck am I saying here? If and I wouldn't draw this on yours because you're going to be drawing a whole lot of triangles otherwise in erasing, but if I draw this right triangle, where I know this angle is 30 degrees, the hypotenuse is 1, the short leg is a half, the long leg is √3 over 2. Well, these are really the coordinates of this point. This point goes to the right √3 over 2, and then up a half. So this point is √3 over 2, comma 1/2. And now why is that important? Well, that's important because since I'm on the unit circle, this is the cosine of the angle. This is the sine of the angle. If I'm going to skip over the 45 and jump up to the 60-degree angle. If I draw a triangle, right triangle to the 60-degree angle, it's going to have the same side lengths, they're just alternated. The short leg is still a half. The long leg is √3 over 2, which makes the coordinates of this point 1/2, comma, √3 over 2. And again, the 1/2 now would be the cosine. The √3 over 2 would be the sine, because the coordinates go cosine followed by sine. And again, there's a fully filled in one that I'll bring up in just a second, and you have on Blackboard, so I'm going to erase these for now. Now let's look at the 45, 45, 90 triangle. If we're going to be assuming we're on the unit circle, that's going to be a 1. Now, from last video, we multiplied by √2 to get the hypotenuse. We'd have to divide by √2 to go back to a leg. 1 divided by √2 will rationalize into √2 over 2. Oops, not √2 over √2, sorry. Just √2 over 2. And the legs are the same length, √2 over 2. So if I just slide that triangle over here, build myself a right triangle. Both legs are root 2 over 2. So the hypotenuse is just, I'm sorry, the coordinates are root 2 over 2, comma, root 2 over 2. So the cosine, oh my, it says cosine. The cosine is root 2 over 2. The sine is also root 2 over 2. Now, if you look at the filled in unit circle, basically those points are going to be the same all the way around. The only thing that's going to change is the quadrant that I'm in is going to change who's positive and who's negative. A few ways to think of this. Think of them as either X and Y, or think of them as all students take calculus. I'm supposed to say all. So let's think about this. In the second quadrant, the sign is supposed to be positive. Well, the sign is the y coordinate. Notice that the signs are positive. The cosines are negative. In the third quadrant, they're both negative. And I mentioned that sine over cosine gives me tangent. If I were to divide these, that would give me a positive number. The tangent's going to be positive, but the sine and the cosines are both negative down here. In the fourth quadrant, the x coordinates are positive. Those are the cosines. The y coordinates are negative. Those are the sines. So it does follow this all students take calculus. And so basically what you have are the same two triangles just repeated over and over again. I'm either looking at a 30, 60, 90 triangle here, or if I get another one to go. Oh, this does not like me. There we go. Down here. Oh yeah, this is not working very well. Let's pause this real quick. And then I'm gonna bring it up on the easier drawing. Okay, so on a little bit easier to draw here. Here's my 30, 60, 90 right triangle. Notice the coordinates. If I flip that triangle over into the second quadrant, the coordinates are the exact same, except the x coordinates switch to negative. Same triangle exists down here, same triangle exists down here. So notice that these coordinates are all the same. It's just who's positive and who's negative. If I look at the 60 degree now instead, let's erase these 30s. If I look at all the 60 degree references, there's a 60, there's another one, here's another 60, and here's another one. Notice their coordinates are all the same. The only thing that changes is who's positive and who's negative. And lastly, if I want to focus on the 45/45s, again, it's the same triangle, just moved around in different quadrants, being flipped and reflected and moved all around in different quadrants, but it's the same triangle. These coordinates are all the same. And again, why is it important to remember these coordinates? Well, all of these coordinates go cosine, sine. So what does this boil down into? A couple different ways to do this. I can either memorize these coordinates around the unit circle, or I can memorize two triangles. One triangle being the 30, 60, 90, where the short leg is a half, the long leg is root 3 over 2, and the hypotenuse is 1, and the 45/45, 90 triangle. And then I just either draw those triangles where I need them, or I again look at these points to figure out my sine and cosine. And then I can figure out anything else if I know the sine and cosine from there. So that's what we're going to be using on the second video here on this section to actually start calculating these.